Welcome back. This is the fifth video for Chapter 7, dealing with arrays. In this video, we're going to take a look at using arrays as parameters and return values from methods. So the rule of thumb, the thing to keep in mind is that we're going to use the same concept that we introduced in video 2 when we talked about declaring arrays. That is that we just make sure that to think of the square brackets as part of the data type. So in that situation, array parameters and return values are just the same as we've seen before. It's just that we tack a square brackets onto the type for the parameter or the return type. So here are a couple simple examples. Here's a signature of a method named foo that has no return value, so it's void. And it takes a single parameter, which is an array of characters. And you can tell that it's an array parameter because the square brackets are after the char, which indicates it's an array of characters. This method, called loadImages, has no parameters, but it has a return type, which is an array of pimage objects. So this method might load up a bunch of images that are required for an application and then return them in an array that we could do something with later. Okay? So let's take a look at this in a couple of examples. First of all, we're going to create a method that searches for a string in an array of strings. So it's a little bit like the method we had, or the code that we had in the previous video, where we were looking at an array and trying to find the smallest value in it. But now we're looking for a particular string. If we find it in the array, we return the first spot where it occurs. If we don't find it in the array, we'll send back a special value, -1, which means that the item wasn't found in the array. So here's the signature line for our method. It will be called linear search. It will take an array of strings named A and a second string called a target, and it's going to return an integer, and that is the index where target is found, or -1 if that target is not found in the array at all. Okay, for this example, we're going to search an array of strings to see if a target is in that array. At the moment, what I've got is a stub here for my linear search method. The signature is what we just saw on the slides, but I'm just hard coding it to return -1 so that my main program will actually work at this point. We'll come back and fill in the details in a minute. Look at the main program then. The setup method is going to do everything. We're going to create an array that has 4 strings in it. Now I'm going to call that search method, linear search, on the array, searching for how. And I expect that it is in there in this case, so I'll just have an if statement that will print that how was found at a certain index, if it indeed was found. If linear search returns a -1, I won't see anything, so I'll know something's wrong. And then in this particular case, I'll search for taupe. I have no idea if that's how you spell taupe, but just pretend. And if it's not found, then I'll get a print that shows me that it's not found. Okay? So let's run it and see what happens. There we go. My stub is working appropriately. It's always returning -1. So that means my first search, which should have found how, is actually failing, as it should at this point. The second one is technically returning the correct value, even though it's not searching at all. Okay, so now we need to go up and we need to write the code for our method body. So my strategy is to look at all the elements in the array, and anytime I look at all the elements in the array, I want a for loop that behaves like this. Okay? Now what I'm going to do is look at every element in turn and see if it's what I'm looking for. So if the array element at spot I is equal to my target, then what should I do? Well, if it's equal to my target, I should return I, and I'm done. By the way, why am I using .equals and not 2 equals signs? Because I'm comparing objects, not primitives. So anytime I compare objects, I have to compare it that way. Now, what would be wrong with doing this? If I didn't find it, I'm just going to return -1, right? Well, no, that's not correct, because that would mean the first time I look at something, if that's not my item, I'll return -1. And that's not what I need. What I need is it to go through everything until it finds it or it runs out of items. So actually, I don't need the else at all. I'm just going to look at every item in the array. If I ever find it, I'll return that index, which will end this method. If I never find it, I'll go all the way through the for loop without returning a value, in which case I can finally do my return -1. So now, there we go. I found how at index 0, and taupe is not found in the array. In our second example, we're going to write a method to create an array of floats, n of them, that are all initialized to a random value between low and high. So here's our signature. We'll call the method makeRandomArray. It takes 3 parameters, n, which is the number of elements to create, low and high, then, which bracket the range of randomness for each element in the array. And the return type will be an array of floats. All right, for our second example, we're going to make a random array of floats based on some parameters that we pass in. And the array that we create will be the return value. So this is the signature from the slides. I've created a stub for that method that just returns null. And then my setup method, the main program if you will just call makeRandomArray. Let's make 50 floats, each between 1 and 1,000. Save a reference to that in the float array reference variable A, and then print that out. At this point, since it's stubbed out, all I see is null down here, which is correct. Okay, so now what we need to do is create the code for the method. So first, we're going to make the array. So it's a array of floats. I'll call it array up here. And how big is it? Well, that's what my first parameter for is n. And now I can return that value. What do you suppose we'd see if I ran this at this point? Notice how now I get 50 floats, all initialized to 0, so we're halfway there. What we need to do now in the method is fill in the values. And again, since we have to do that to every value in the array, we need a for loop. Like that. And hopefully that pattern is becoming familiar to you by now. And what we'll do with each element is make it equal to a random value between low and high. Oops, wrong button. There we go. And now all these values are randomly initialized between 1 and 1,000. One thing that's important about the way processing and its parent language Java work is that every parameter is passed using what's called pass-by-value. So in pass-by-value, a copy is made of an item when we call the method, placed into the parameter variable inside the method, and that means that any changes that are made to parameters inside a method don't affect the original value. However, it's important to realize that we have object references for objects. In other words, objects are always referred to by a reference variable. And so when we pass a parameter that is a reference variable, what we're passing is the address to an object. And any changes we make to that address in the method won't affect the original value in the calling method. But any changes we make to the object on the other side of that method do affect that value. So let's take a look at a couple of examples here just to illustrate pass-by-value versus what's called pass-by-reference, and then we'll sum it up. So This first example, what we're going to do is have a method called setup that calls a method foo, and we'll see how as we pass that parameter into foo, its value is copied. So its value will start at 13, it'll be 13 in the new method, and then any changes we do here in foo won't have any effect on this value. So let's take a look at that in code real quick. Okay, now let's take a look at pass by value and how that works. In this case, I have a setup method that has a variable named I in it, and I'm going to pass that down to a method named foo. Okay, so here's my method up here. I haven't really filled in the details yet, but let's suppose in foo we get a little angry with the parameter I, and we'll change it to negative 387. Okay, then we'll have it print out, and I'll put a couple tab characters in there so we know that it's inside the method. Oops. Okay, so we'll print out its value, which should be negative 387, and then in setup actually what we'll do is print out the value as well. So I'll print it out before, call the method, then print it out again. So what do you think we're going to see? Well, let's find out. It's 13 in setup, that's this line, before I've called the method. Then inside the method, the parameter is changed, and then I print out the value, change it to negative 387, excuse me, and then finally, after the method, it's back to 13. That's because pass by value means this parameter up here, I, this guy right here, is not the same value as this. Even though they have the same name, I just take the value of I, put it into this variable parameter, which also happens to be I, but it's a totally separate box. And so whatever I mangled up in here in foo has no effect in setup. Now for this second example, using what's called pass by reference, we're going to have to switch languages. So we're going to use C++ instead of processing, because processing doesn't support pass by reference, at least for scalar values. So in this example that we're going to see, we'll see that main, which is pretty much like setup in processing, will call a method named foo, pass a parameter in, but what foo really gets is the address of this parameter or this item in main. And so any changes that foo makes will in fact change the value over here. Okay, now what we're going to look at is this C++ program that shows pass by reference. It'll be pretty much the same structure as the previous one. I have a stub here for foo at this point, and I have my main program that declares a variable, prints out its value, calls the function or method, and prints out its value again. So the structure of this is very similar to what we just did in processing. Now the difference is up here that we're going to pass by reference, which you indicate in C++ with that and sign. And now if I make a change, notice I've named the parameter differently. It's not important, but I did at this point. I can change the value of the parameter, just like we did before. And then let's see what happens with this. So I've changed the parameter, printed out its value, just like we did before. So need to compile the program. Oh no, we have an error because I forgot one of my tab characters. Now let's try that again. Very good. And then when I run the program, oh, look at that. Okay. See what's happened? With a pass by reference parameter, the change made inside the method affects the value outside. So that is a big deal. Things that are passed by reference, changes made in the methods affect the values in the calling methods. To sum this all up, even though processing uses pass by value, in effect, when we pass in an array parameter, we're passing by reference because we're getting the reference to the object, and therefore any changes that we make to the array in a method are permanent to the calling method. And happily, that's often how we want it, in particular for a task called sorting, where we rearrange the items of an array to put them in some particular order. So that will be the topic of our next video, the topic of searching and sorting.